Good morning, dear student. I am Rupak Shah from the Millennium School, South City, Lucknow. Today I will be taking you lecture number 8 for the chapter Electricity. Before we start for today's content, just recap for the last lecture that I have given. We have done some numerical on law of combination, and for doing those numericals, you should remember that the formula used for the series will be Rs is equal to R1 plus R2 plus R3 plus dash 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 Rn. For the parallel, it should be 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 dash dash 1 upon Rn. Already we have done 3 numericals based on law of combination. So we are going to use this formula for the series, and you're going to use this formula for the parallels. And in case you are to find the current, we need to use this formula I is equal to V upon R. So you must be clear about all these formulas and all the laws of combination methods which has to be used during the numericals. Today we will be taking some more numericals, some more practices, but these topics should be taken again and again, and at least you should view the videos 2 or 3 times, practice them well, and no queries or no such type of problems in your mind. If you have any queries regarding all these things, that should be conveyed to us during the Zoom session. So today I am taking one more numerical which is supposed to find the total or equivalent resistance, total current, and PD across R1. Please see the circuit properly at least for 2 to 3 times. So you are given with R1 5 ohm, you are given with R2 20 ohms, you are given with R3 again 20 ohm. But this is a mixed circuit. I told you that there is a parallel combination also and there is a series combination also. So if you want to find the equivalent or a total resistance of this given circuit, what step has to be followed? That has been already told you in the last lecture. In the such type of circuit, we are supposed to find the resistance in the parallel, and then whatever the resistance you get in the parallel, that should be added with the R1 in series. So I will show you the step once again, that how we are going to do, and the steps first for the R. So let's come for the calculation first. So first, when we find for the parallel, 1 upon R is equal to 1 upon 20 plus 1 upon 20, because these two are connected in parallels. So 1 upon R is equal to 2 upon 20, reciprocal them, 1 upon 10, R is equal to 10 ohm. So reciprocal, then you get a now resistance in the parallel. But I told you that when we take the resistance, when we are taking this circuit particularly, you have seen that parallel is connected with the R1 in series. So we have to add them in series. So 10 plus 5, you get 15 ohm. So this step should be again clear. I told you in the last examples also in the previous lecture that parallel has to be first added, and whatever the result you get in the parallel has to be added with the R1 which is connected in series. So you get a 15 ohm. Now for I, we are using the formula from the Ohm's law, V upon R, everybody followed. What is the V given in the circuit? 30 volt. And what is the R you just taken out? 15. So if you cancel them, you get a 2 ampere. So this step is clear for equivalent resistance, that is called total resistance, and the current. Both you have found out. Now if you want to find the PD across R1, what is the voltage in R1? So you have to use IR1, because current is common in both the circuits. So if you take the diagram once again, I'm just showing you, the current in this and current in this are going to be same. Can you tell me why? Because this portion and this portion, the current is, they are connected in series. So in series, the current are going to be same. Let's forget this portion at this moment, because we have to deal with this portion only. So here the current is the same, what you have found out just now, 2 ampere. And what is the resistance here? 5. So we are not concerned about this circuit at this moment, we are concerned about this one. So let's come to this portion, IR1. So what is I2? Was going to be same in that portion also, that portion also. So 2, and what is the R1? 5. So what is the voltage across PD across R1? That comes 10 volt. So these are the most frequently asked question in the circuit based questions. We will be practicing them in more examples in the coming lectures or coming videos. But at this moment, as far as the circuit is concerned, these questions are most common. You practice them, and if you still have any problem, you can convey to us, and we can clear them with more practice, more questions, and at the same time we can discuss in the Zoom session as well. So I hope we are coming to the another pattern of finding out the resistance. Now here I have taken a different type of question in which this question is asked: a wire of 10 ohm is bent to form a circle. What is the resistance across diametrically opposite ends? Now this type of questions are very frequent nowadays. It is very frequently asked in board examination. So what we have done, we actually bent the wire of 10 ohm in the form of circle. And these are the two ends where we are supposed to find the resistance at the diametrically opposite ends. So when we do this, this portion and this portion becomes parallel. Because here your currents are dividing. You have to understand that where the current is dividing, the current cannot remain same. The current is dividing, this portion becomes parallel and they will be equally dividing. If it is 10 ohm, it will be 5 ohm here. For example, if the question is 5 ohm, it will be 2.5 here. If it is 20, 10. Are you understanding? It means along both the sides, that is opposite end of the A and B, these are going to equally divide. If it is a 10 ohm, it will be 5 and 5. I told you if it is 20, it will be 10 and 10. I think this should be clear by now. So if this circuit is given to you, you have to find this in parallels, and the R1 will be taken as 5 ohm and R2 will be taken 5 ohm. So 1 upon R is equal to 1 upon R1 plus 1 upon R2. So 1 upon R is equal to 1 upon 5 plus 1 upon 5. So we add them, 2 upon 5. Taking the reciprocal of them, when you take the reciprocal of them, it becomes 5 upon 2. Always take the reciprocal of the parallel combination. So answer comes 2.5 ohm. So this type of questions are normally asked nowadays in the board examination apart from the normal circuit. So I hope it is clear. So let's move to the next question. Now this will be some numericals based on resistivity and resistance. So today we are taking a one pattern of the question which is asked regarding resistance and resistivity. In the coming lectures, we will be taking more questions on resistivity, we will be taking more questions on power, we will be taking some more numericals on heating effect. Already we have gone through the definitions, we have gone through the formulas, we have gone through the concepts. By now, all the concepts should be clear by now. So now we are going for a numerical sessions. So when we are in a numerical session, you are supposed to observe the video for at least 2 times, practice them of your own, and the queries should be written with you, and whenever we interact with you in the Zoom session, that those queries should be given to us so that we can come across what difficulty you are facing, because at this moment we are not able to understand which type of question you may face problems. So let's take assumption that you are understanding well and you are doing the practice, but when there is interaction, you must tell what is the problem. Now in the question number 1, a wire of 100 ohm is stretched to double its original length. What is the new resistance? Please understand, there is a one wire whose resistance is given 100 ohm. Now what we have done, we have stretched the wire to double its original length. So we have stretched it and we made 2L. Initially, for example, its length is L. So if you stretch it double, this length will become 2L. Now what is the new resistance? So I am giving you some steps, please follow them clearly. R is equal to rho L upon A, which is given as 100 ohm. Now one thing should be noted, that the volume of the wire should not get changed. Volume of the wire means the formula used is V is equal to LA. Please follow this. Volume is length into area. So if you want to maintain the volume same, the length, if it is doubled, because we have stretched it double, area should be half, so that when we cut it, the volume will remain unchanged. Are you understanding? It means if its length is 4 times, it will be A by 4. If its length is increased by 5 times, A by 5. So it cancels and your volume always remains same. So this step should be clear by now. volume should not change. If your length is increasing 2 times, your area will decrease by 2 times. So if you use in the new formula, that is the new one, R dash or R1, rho length has become 2 times, your area has become half. So 2, we can easily see that this 2 goes up. I'm sorry. So when this 2 go up, it becomes 4. And if you take this 4 up on this side, taking all the values over here, you are left with rho L upon A. Please follow this step again. 2 goes up, 4. We have taken 4 this side, rho L upon A on the other side. Rho L upon A is equal to R. Rho L upon A is R. So we are going to substitute this value over here. So R1 or R dash, what you have taken is, now we have put the value of this one R. So R1 is equal to 4R, and what is the value of R given? If it is not given, you can write 4 times. The new resistance has become 4 times. But if R value is 100, so you can put this value here. So 100 R1, or you can say the new resistance R dash you can take also. So 4 into 100 you get 400 ohm. So what is the conclusion you've taken? New resistance becomes 4 times. If it is 100, it will be 400. If it is 200, it will become 4 times. If it is just double, so it will become 800. So in the same way, we can do the other steps also. I hope it is clear. Please practice. Please see them 2 or 3 times. You will not have any problem in that. So we are taking one more example in a reverse pattern. If a wire of 10 ohm is just doubled on it, what will be new resistance? If a wire of resistance 10 ohm is just doubled on it, what will be the new resistance? It means this is the wire and we had doubled on it, means it is doubled on it. It is a single piece of wire and it is doubled on it. Now if you are taking a wire and if you are just making a fold of, if you want to double on it, you have to double from here, no? You cannot double from here. So if you double on it, what is happening to the length? The length is becoming half now. So this particular wire is doubled on it. Same wire is there, so it is doubled on it. So it is doubled. So the length becomes half. Following. So this is a particular thing that we have to understand. And your area will become double. I told you to keep the volume same. Length, if it is become, area becomes double. So this step should be followed to you. In this question, length is half. In the previous question, it was double. So it is half, area becomes double. Just to cancel them, if you cancel them, the volume becomes same. So now come to the new resistance. R dash is equal to rho L upon A. So instead of L, what we have put? L by 2. In the area, we have put 2 by 2A. So 2 goes down, you get a 4. And you get 1 upon 4 rho L upon A. So if this value is R, so what you find? R dash is equal to 1 upon 4R. It means whatever the value you are getting, new resistance you are getting, that is 1/4. It becomes 1 upon 4, not the 4 times. So what you have seen in the previous question, if your length is doubled, it becomes 4 times. But if your length is become half, then your resistance decreases. So it will become 1/4 of the original one. Please follow these numericals for at least 2 to 3 times. Understand them. These questions are very, very important. That questions I have given for the resistivity, the question I have given for the Ohm's law. These questions are the most common questions which are coming. Other questions based on other circuits, other type of circuit, that will be taken during the numerical practice in the next session. So we are just assuming that now all the steps are clear till now, and I told you that all things should be conveyed to us during the Zoom session if you have any problem regarding numericals. Dear student, you have been given the Google Classroom platform for posting your homework. Especially the classes who are given the code for the classroom, Google Classroom code, they should join them immediately, because from the next video onwards or this video onwards, we are going to post your homework or even assessment in the Google Classroom. You may not lose your marks, you should not lose your any particular assignment. You must join them as soon as possible, and if you have any queries you can give us a call and we'll solve your problem, but you must join your Google platform as soon as possible. I hope it is all clear. Thank you so much and stay safe.